Hello, we are doing notes on expanding expressions today, the elusive topic 7-1 that you guys have asked about. This topic, I feel like we have had a pretty good introduction already with the distributive property, so there isn't going to be a lot of new information. Let's just first look at the key concept that says that the algebraic expression 3 then times x plus 2 is a product with two factors technically. The first factor being the 3x and the second factor being the x plus 2. It says you can use the distributive property to rewrite the product as the sum of two terms. So if we look here, they have the product. They're showing you your two factors, right here and here. Then when we use the distributive property, the 3 times x becomes 3x, and the 3 times 2 becomes positive 6, and now that has two terms. Again, I think that you guys are pretty fluent with that concept now. Looking at the second part, they are showing us that if you have a negative 2, the negative 2 times the negative 3y, they're writing right here for us, and then the negative 2 times the 5, they're writing right there. Now, they aren't just doing the multiplication, they're showing you the steps to getting the answer. So now they're saying, well, the negative 2 and the negative 3, you can multiply those together. Even though negative 2 and negative 3y are not like terms, you can multiply the coefficients still, and then you just attach the coefficient. No, variable. Then with the negative 2 times 5, again, those are just constants, so you can certainly multiply those together. They are showing you that you can write your final answer as either 6y plus negative 10 or 6y minus 10. They both are equivalent to each other. So I'm just going to ask that you guys go ahead and practice number 1. Do all 3 examples. Go ahead and check your answers. Number 2, same deal as saying which expressions show a sum or difference equivalent to negative 1/5 times negative 5m plus 10. So they want this to show a sum or difference. When you look at the first choice, technically this one is two products. Even though it is equivalent, because they switched the negative 5m, they put it here, and they put the positive 10 here. They switched the order, but even though they switched the order, it's still equivalent. But because it doesn't show a sum or difference, that one doesn't work. That shows two products. On this one, when you are multiplying negative 1/5 times negative 5, you get a positive m. 1/5 of 5 is 1, so you get positive m, so that's why m minus 2 would be equivalent here. That one does show a difference. This one here is showing you a negative m, so that would not work. Now, the next page is just a big bunch of key concepts. It says that you can expand an algebraic expression when you use the distributive property to rewrite a product as a sum or difference of terms. And what they are showing you here is how you can apply the distributive property even if the number is not necessarily on the left. This one here is our traditional way that we normally use the distributive property. Our number here is on the left. They're distributing that 1 5/10 to both terms inside the parentheses. Then they've used the associative property to now reassociate that they're going to put the 1 5/10 times 2, and they can simplify that out. Now, on this next one right here, they are saying, well, you can still have the number being attached to the parentheses multiplication, but you'll need to multiply from the right. Then they are saying using the commutative property, which changes the order. So I want you to see that they're saying 5 times b. They originally wrote it as b times 5, but using the commutative property, we like to put the coefficient in the front, so that's why they've now switched and put 5b, because that's equivalent. The next one also talks about how you can distribute a variable. You can distribute a variable in the same way that you would distribute a digit, but they don't simplify. So looking at this, you've got y times 2x. Well, you can just put the coefficient of the 2 on there, but then you just change the order. So looking here, they put the y first and then the 2x. Then using the commutative property, they've now switched the order, so it says 2x times y. And then by the associative property, they've just dropped the parentheses to now say that that is the same thing as 2xy. Now, most of you are going to be able to get to this step without doing any of these other steps here. The next one talks about distributing a negative number, and you have to make sure that you're careful with your negative signs. And we've talked about this when we had just the negative outside of the parentheses. We've talked about what has to happen to the numbers. So you can take a look at again at what the answer is supposed to be. And the last one talks about distributing over 3 terms. You can really have as many terms as you want inside the parentheses. If there is a number on the outside of those parentheses being multiplied, you have to multiply that number to each term inside the parentheses. So in this case, there are 3 terms. That number 1/3 is getting multiplied 3 different times. You can certainly write out the step right here like they have, if that helps you, especially when you have a fraction times a number. But again, if you're fluent with what the number is that you're multiplying by, you can also just get right to your last step. So the next example says that they want us to determine which 3 expressions can be expanded and then write them in the box and then expand. So I'm just going to go through and decide with you which ones can be expanded and which ones can't. 7m plus 7n, you cannot expand that. That is showing a sum of 2 terms. The 3x times 2y, technically you can't expand that because there is only 1 term inside the parentheses. Then the 6a minus 10b times a half, that one can definitely be expanded. The -4 then just can be expanded to the x, the 10y, and the 9. And the last one, the 3x, the 2 plus y. Please go ahead and expand those 3 expressions. Okay, so I went through, and even though the 1/2 is on the right side, I'm distributing that to each term inside the parentheses. So 1/2 times 6a, bring down the subtraction sign, 1/2 times 10b, and then I say 1/2 of 6 is 3, 1/2 of 10 is 5, bring down my subtraction sign again to get 3a minus 5b. For the second one, I need to make sure that I am distributing that -4 to each of the terms, so that x now becomes -4x, the 10y, positive 10y becomes -40y, and the -9 becomes positive 36. And on the last one, the 3x times 2, I do combine the coefficients by multiplication to get 6x, and then 3x times y just becomes 3xy. Number 4 is very similar. They're just asking you which expression can be expanded, and then write the expression in its expanded form. So go ahead and try that one on your own. Go ahead and take a look at this one. I'm showing you more of the thought process behind how I got the answer of -5y plus 5x. Be mindful that the y and the xy are not like terms because they both don't have an x in them. I'm just showing you that the only one that could be expanded, the only one that can be expanded is the one that's showing the multiplication. This one is showing subtraction, so you're not subtracting that number or that letter to both terms. Question number 5 says that for your birthday party, you plan to buy 2 cupcakes for each guest and 5 additional cupcakes to have as extras. Cupcakes cost $2.25 each. Let X represent the number of guests you invite to your party, and then use the expression $2.25 times 2x plus 5. What does each factor of the expression represent? And then what does the expression represent itself? Now, when you have these questions on your test or on your homework, they are going to be giving you multiple choice options here. So we are going to be doing a little bit of writing, but it's okay. So they're saying, what does each factor of the expression represent? So right here is asking you what factor each of those represents. The 2 and the $2.25 is the cost of each cupcake. That is one term of our one factor, of our expression. Then the 2x plus 5, that would represent the x is the number of people that are at the party. So 2 times that would mean that every person gets 2 cupcakes and the 5 additional. So the 2x plus 5 is the number of cupcakes purchased, and that's not a hashtag. Number of cupcakes purchased or number of cupcakes needed. And then the whole expression represents how much money you would be spending on the cupcakes. Okay? Part B then is asking you to use the distributive property to expand the expression. And then what does each term of your new expression actually represent? So the expression that they gave us was the 225 times the 2x plus 5. If I was to use the distributive property, I'm going to multiply 225 times 2, which will be 4 5/10, or 450x. And then 225 times 5, which will give me 1125. And now they're asking you, what does each term of this expression represent? And again, this expression is showing the sum of terms, not the two factors. So this one, the 4 5/10 x, represents the amount of money you spend on X amount of people. So the amount of money spent on each person. And then the 1125, well, if the 5 represented the 5 additional cupcakes that we were purchasing, and we've now multiplied that by the cost of the cupcakes, that represents the additional amount of money we would spend on 5 cupcakes. This is the cost of 5 cupcakes. Cost of the 5 additional cupcakes. Cost of the 5 additional cupcakes. And again, when you're completing your homework or taking the test, they will be giving you multiple choice options here. On the back, question number 6 says that an architect draws plans for extending a rectangular deck. Let x represent the increase in meters of the deck's length. They are now giving us the expression 3 7/10 times 4 5/10 plus x. They're again asking us what each of those factors of the expression would represent, and then what does the expression represent. So the 3 7/10, that is this right here, that would represent the width. The 4 5/10 plus x would be the length of the extended deck, because that includes the original deck plus the new portion. And then the 3 7/10 all times the 4 5/10 plus x would be the area of the new deck. Then the second part again is asking us to use the distributive property to expand the expression, and then what does each term of our new expression represent? So 3 7/10 times the 4 5/10 plus x. 3 7/10 times 4 5/10 is 16 65/100. 3 7/10 times x will be 3 7/10 x. So the 16 65/100 is the original area of the deck, and the 3 7/10 times x is the area of the new deck. Okay, thanks for watching, guys. Again, if you have any questions, please be sure to ask me tomorrow or whenever the questions arise. Have a great night.